Welcome to Day 7 of the 60-Day Cloud Security Challenge. For the past 2 days, we covered VPC architecture and security groups versus NACLs. Today we put it all together. We are building a complete, production-grade VPC from scratch. Not a toy demo, this is the actual pattern I use for production workloads that need to pass SOC 2 and PCI audits. Let me start with the scenario. We have a standard 3-tier web application. A public-facing application load balancer, backend application servers that should never be directly reachable from the internet, and a PostgreSQL database that should only communicate with the app tier. 3 tiers means 3 isolation levels in our VPC. First decision is CIDR planning. I use A/16 for the VPC, which gives us 65,536 IP addresses. Subnets get /24, giving 251 usable IPs each after AWS reserves 5. The key is the numbering convention. Public subnets get 1 through 9, app subnets get 10 through 19, database subnets get 20 through 29. This matters more than you think. When you are debugging a security incident at 2 a.m. and see traffic from 10.0.21.47, you instantly know that is the database tier without looking anything up. Next, we set up routing. This is where the actual isolation happens. The public subnet gets a route table with a default route pointing to an internet gateway. Standard stuff. The app subnet gets a route table with a default route pointing to a NAT gateway. This lets app servers pull security patches and send logs to external services, but no one on the internet can initiate a connection to them. The database subnet gets a route table with no default route at all. Just the automatic local route for VPC traffic. This means even if malware somehow lands on your database server, it physically cannot reach the internet. There is no route for the packets to take. One important detail about NAT gateways, they go in the public subnet, not the private one, 230 to 330, now for security groups. The pattern here is chaining. The ALB security group allows HTTPS from anywhere on port 443. The app security group allows traffic on port 8080, but only from the ALB security group. Not from a CIDR range, from the security group itself. This is important because when instances scale up or down, you do not need to update IP-based rules. The security group membership is the identity. The database security group allows PostgreSQL on port 5432, but only from the app security group. So the chain is internet to ALB to app to database. Each hop is explicitly permitted. Anything else is denied. NACLs are our safety net. I think of them as the backup control. If a junior engineer accidentally opens the database security group to 0.0.0.0/0, and this happens more often than you would expect, the NACL still blocks everything except the app subnet CIDR. Here is the gotcha that gets everyone. NACLs are stateless. Unlike security groups, they do not track connections. When your database receives a query on port 5432 and sends back results, the response goes out on a random ephemeral port between 1024 and 65535. If your NACL egress rules do not allow that port range back to the app subnet, the response gets silently dropped. No error message. No rejection. Just a timeout on the application side. This is the single most common NACL debugging issue I encounter. 430 to 515, VPC Flow Logs are non-negotiable. Without them, you have no network-level audit trail. Enable them on the entire VPC, capture all traffic, not just rejected, and set the aggregation interval to 60 seconds instead of the default 10 minutes. The cost difference is minimal, but you get near real-time visibility. Send logs to both CloudWatch for active alerting and S3 for long-term retention. Set up a lifecycle policy on the S3 bucket to move logs to Glacier after 30 days and delete after a year. Flow logs generate a lot of data and you do not want a surprise storage bill. Capturing accepted traffic is just as important as rejected traffic. During a breach investigation, accepted flow logs show you exactly what the attacker accessed and any lateral movement within your network. After deploying all of this, validate it. SSH into an app instance and confirm curl if config.me returns the NAT gateway elastic IP. Try connecting to the database from the public subnet, it should fail. Check your flow logs after a couple minutes and confirm you see reject entries for that blocked attempt. Run describe route tables and verify the database route table has no default route. Common mistakes to watch for: auto-assign public IP on private subnets, using the default NACL which allows everything, running a single NAT gateway in production, and routing S3 traffic through the NAT gateway instead of using a free gateway endpoint. That is your secure VPC. 3 tiers: defense in depth with both security groups and NACLs, no unnecessary internet exposure, and full audit logging. Tomorrow on day 8, we move up the stack to CloudTrail, where we track every API call made against this infrastructure. See you then.